This is Geometry, Chapter 1, Section 7, in which we will discuss three-dimensional figures. Last time, if you recall, we did two-dimensional figures, hexagons, octagons, things of that sort. This time, we'll be dealing with three-dimensional figures. So we need to learn some terminology here. A polyhedron is the fancy term for a three-dimensional shape. It's a solid figure that has all flat polygonal surfaces. That means they're made up of polygons. Those surfaces are called faces. Okay, and they enclose a single area or portion of space. They close up together. The segments where two faces meet are called edges. And the point where three or more faces come together is called a vertex. The plural of that word, we use it a lot more than we use the singular. The plural is vertices. Okay, so just basic terms on 3D figures. If a polyhedron has two parallel and congruent bases, two bases that don't intersect each other in any way, and they're identical, then it's got a special name. It's called a prism. If it only has one single base and then it has a bunch of triangles that come up to meet at a point, it's called a pyramid. Okay. And in the classroom, I will have some examples of what some of these things look like. So if you need to see those, just ask. Don't have all of them, but I have some anyway. The way we name a polyhedron, polyhedra is the plural of that. The way we name them is based on the shape of the base. If a prism has a six-sided base, then it's called a hexagonal prism, six-sided hexagon. Making it an adjective puts the AL on it, so hexagonal prism. If we have a pyramid with five-sided base, that would be called a pentagonal pyramid. Pentagon, five sides. Okay. If we find the areas of all the faces and then add them together, we get what's called the surface area of the solid. And if we measure all the space that's contained inside it, we get something called the volume. Okay. On our next page here, I've got a bunch of formulas for you to find the surface area and to find the volume of the different shapes. You have these on your note sheet. I didn't make you write all these down this time, like we did with the other one. But you have these in front of you on your note sheet. We're going to refer back to this page. I'm not going to flip back on the video, but we'll refer back to this to get the formula we need for the shape we're looking at. In your assignment, you're going to be asked to find a bunch of volumes and surface areas and things of that sort. So you're going to need to recognize what shape you're looking at and use the proper formula. So we have two solids to work on. And our job is to find the surface area and the volume for each one. We'll deal with this guy over here first. This prism, this box. Okay. Well, the formula for the surface area of a box, a prism, is to find the perimeter of the base times the height plus 2 times the area of the base. The perimeter of this base is 8 plus 4 plus 8 plus 4, which adds up to 24. times the height, 3, plus it says 2 times the area of the base, well that would be 8 times 4. Doing a little arithmetic, that's 72 and that's 64 added up is 136 square inches. Volume is the area of the base times the height. If it happens to be a rectangle, then it's the formula you've known all your life, length times width times height. In this case, that's what we're looking at. So 8 times 4 for the base times 3 for the height gives us 96 cubic inches. When you're in volume, it's a cubic unit because it's 3 dimensions. So there's your rectangular prism type deal. Let's do one over here. This shape is called a cone. If you turned it upside down, you could put ice cream in it. If you turn it this way and put ice cream in it, it's going to fall out and then we cry. Well, on our previous page, we have formulas for a cone. The surface area of a cone is half pi times the radius times the slant height plus pi r squared for the base. Well, let's plug in. Half of pi times 3 is the radius, 5 is the slant height, plus pi times 3 squared. My calculator, when I punch that in, gives me 23.562, and this part gives me 28.274. I must have used the pi button this time instead of 3.14. So I get 51.836 square centimeters. Again, if you use 3.14 instead, you'll have a little bit different answer, but it'll be close to that. So that's our surface area. Volume for a cone is 1/3 times pi r squared times h, the height. So plugging in the values for the radius and the height, and then punching into my trusty calculator, I get 37.699 cubic centimeters. It would take quite a lot of time to go through each kind of shape, so we're only going to do a couple here, and then you'll have plenty of time to ask questions during your work time on the other shapes if we didn't get to those. And as always, if you had questions, hopefully you jotted those down on your note sheet, bring those in with you, and we will see you in class.